In a bold declaration, researchers have announced the discovery of an entirely new planet unlike any other identified before. NASA, famous for its groundbreaking research, has revealed that this newly found planet is intriguing, not just because of its size and position but also due to the fact that it emits light that appears to be artificial. Could this groundbreaking discovery be a sign that we are about to reveal mysteries that will fundamentally change our comprehension of the cosmos? Does this information imply the possibility of life existing on planets beyond our own? As we delve into NASA's amazing discoveries, we may soon uncover the truth behind these extraordinary lights. In 2007, NASA launched the Dawn spacecraft on a mission to investigate some of the most enthralling objects in our solar system. Equipped with 3 ion engines, Dawn embarked on a journey that began with a 14-month study of Vesta, the second-largest asteroid in the belt. Dawn transmitted back intricate images and data, revealing Vesta's complex surface and rich geological history. Upon completing its mission at Vesta, Dawn proceeded with what was arguably the most exciting phase of its journey, an in-depth look at the dwarf planet Ceres. Thanks to its ion engines, Dawn was able to leave Vesta's orbit and head toward Ceres, a feat that traditional chemical propulsion methods could not have accomplished. These engines provided a constant thrust, allowing Dawn to travel vast distances and establish a stable orbit around Ceres. Discovered in 1801 by the Italian astronomer Giuseppe Piazzi, Ceres is the largest object in the asteroid belt between Mars and Jupiter. For many years, it was regarded as the smallest dwarf planet in our solar system until its reclassification in 2006. With a diameter of about 950 kilometers, Ceres is the largest and most massive body in the asteroid belt, making it one of the most intriguing objects due to its distinct features. Scientists eagerly anticipated the first comprehensive images of this mysterious world, which revealed bright spots scattered across its surface, particularly within a large crater. These spots immediately captured the attention of the scientific community. Before the Dawn mission, the best images we had of Ceres were blurry, low-resolution pictures captured by the Hubble Space Telescope. Very little was known about this dwarf planet, and the possibility of obtaining close-up images promised exciting new insights. The Dawn mission aimed to deepen our knowledge of the solar system's formation and the role water played in the development of planetary bodies. The bright spots on Ceres, also observed on other asteroids, were believed to be composed of highly reflective materials, possibly salts left behind by sublimated water. This discovery hinted at the possibility of cryovolcanism on Ceres, a phenomenon where lava flows consist of substances other than molten rock. But what exactly is brine or liquid water? What do these enigmatic lights represent? What do they reveal about Ceres? These remain open questions. Could they be evidence of ongoing geological activity, or could they indicate something even more remarkable? Ceres stands apart from other objects in the asteroid belt due to its size, mass, composition, and potential for containing water and ice. Unlike standard rocky asteroids, Ceres has a composition more similar to that of a comet, suggesting it may hold valuable secrets about the early solar system. After 2 years of travel, the Dawn spacecraft finally began its approach to Ceres in early 2015, marking a significant turning point in its mission. As it prepared to send back the first close-up images of the largest object in the asteroid belt, the spacecraft drew closer to Ceres, revealing a world previously hidden from view. The first images of Ceres displayed a cratered surface indicative of a long history of impacts. However, it was the gleaming areas within the dark, rocky terrain that attracted the interest of scientists and space enthusiasts alike. As the resolution of the images improved, scientists developed various theories. Could these bright patches be sunlight reflecting off ice, or could they represent something even stranger? Speculation ranged from mineral deposits to potential signs of cryovolcanic activity. To everyone's astonishment, closer inspection revealed that the brightest spot was not a single feature but a cluster of several distinct spots. The most widely accepted explanation was that these spots were deposits of salt left behind by the sublimation of water. This implied that Ceres might still have some form of geological activity capable of bringing water or brine to the surface, where it quickly disappears, leaving behind brilliant reflective traces. These findings challenged preconceived notions about Ceres, presenting a new image of a dynamic and complex world. The possibility that groundwater or brine pockets exist beneath the surface raises intriguing questions about the potential for life elsewhere in our solar system. Ceres is frequently referred to as an icy world with a porous yet rocky surface. Unlike most asteroids, which are primarily composed of metal and rock, Ceres stands out due to its distinctive composition. Its surface consists of a mixture of water, ice, and hydrated minerals, including carbonates and clays, giving it a lower density than its rocky neighbors. This composition implies that Ceres contains a significant amount of water, with a porous surface made of rocks containing trapped ice and other volatile materials. This makes it more similar to a comet than a typical asteroid. Scientists believe Ceres has a unique internal structure, consisting of a muddy mantle and a core with abundant water ice, accounting for about 50% of its total volume. The mantle is thought to be a mixture of brine and rock surrounding a core that may consist of denser substances, such as silicates. The presence of significant water ice suggests that Ceres may have hosted liquid water in the past, particularly if its core was heated by radioactive decay early in its history. In the past, this internal structure was a distinct group from other asteroids and raised intriguing questions regarding the possibility of geological activity and the role of water in its development. Moreover, ammonia clays were discovered on Ceres, raising the question of whether the dwarf planet may have originally formed in a cooler region of the solar system before it moved inward. The presence of ammonia may decrease the freezing point of water, supporting the existence of surface brines. Perspectives on the composition and history of Ceres not only deepen our comprehension of this enchanting dwarf planet, but they also provide useful clues about the processes that govern the formation and evolution of icy bodies across the entire solar system. Cryovolcanism is an intriguing and relatively rare geological phenomenon, particularly in comparison to the more common eruptions of volcanic ash on Earth. Unlike conventional volcanoes, which spew molten rock, cryovolcanoes, often referred to as ice volcanoes, eject substances like water, ammonia, or methane in liquid or gaseous form in extremely cold environments. For example, cryovolcanoes on Ceres function by allowing briny water with dissolved salts to reach the surface. When this salty water comes into contact with a vacuum of space, it rapidly sublimates, turning directly from solid or liquid into gas. This process results in bright, reflective salt deposits, which make up the bright spots observed on Ceres' surface. The most well-known of these shining spots is located within a crater, particularly in the area known as SP5. This area has garnered significant attention due to its high reflectivity and the regular shifts observed. These fluctuations are believed to be caused by water sublimation, suggesting that cryovolcanic activity could still be occurring or may have recently occurred on Ceres. In addition to SP5, Ceres hosts numerous other bright spots, each with unique features. These locations are not restricted to a single area but are dispersed throughout the dwarf planet's surface, implying that cryovolcanism may be a widespread feature. These bright spots underscore the dynamic and active nature of Ceres, challenging previous assumptions that it was a geologically dormant world. As the Dawn spacecraft continued to capture more detailed images, a wide variety of surface features emerged. Ceres is covered with a diverse landscape, each feature telling the history of this dwarf planet. As the Dawn spacecraft carried on with its observations of Ceres, the scientific community remained intrigued by its mysteries. Each new discovery raised more questions about the dwarf planet's past and its potential to support conditions favorable for life. The presence of bright spots and signs of cryovolcanism painted a picture of an active world, far more dynamic than initially thought. This discovery suggests that Ceres might not only be a remnant of the ancient solar system but also a world where ongoing geological processes, such as the eruption of ice and brine, continue to shape its surface. The fact that Ceres could maintain such activity despite its small size challenges conventional wisdom about celestial bodies in the asteroid belt. Traditional perspectives suggested that bodies in colder regions of the solar system would be geologically inactive and frozen in time. However, Ceres' ongoing activity hints that even in the coldest reaches of the solar system, the right combination of heat, water, and salts might be enough to power cryovolcanic eruptions. Another important aspect of Ceres is its ability to provide crucial clues about the history of water in the solar system. Water is a key ingredient for life as we know it, and discovering that it may exist in liquid or brine form on Ceres opens up new possibilities for the existence of life in environments far from the sun's warmth. The notion that both water ice and liquid water may have once existed on Ceres suggests that other celestial bodies, such as Jupiter's Europa and Ganymede, or Saturn's Enceladus, may also host conditions favorable for life. This makes them prime targets for future exploration. The possibility of cryovolcanism occurring on Ceres also leads to deeper questions about the mechanisms that drive such processes. How does groundwater beneath Ceres' icy crust remain in a liquid state despite the freezing temperatures of space? Could there be internal heat sources, such as radioactive decay or tidal heating from gravitational interactions, keeping the water beneath the surface warm enough to remain liquid? Understanding the nature of these internal heat sources could offer important insights into the geological evolution of other icy bodies in the solar system. Ceres' dynamic surface features, ranging from its bright spots to its craters, help us better understand the history of impacts in the solar system and how smaller bodies have evolved over billions of years. Each crater on Ceres provides scientists with a glimpse into the forces that have influenced not only Ceres itself but also many similar bodies in the solar system. To determine whether these effects were the result of asteroid collisions or other cosmic events, scientists continue to study the unique aspects of Ceres and its role in the larger narrative of the solar system's development. Moreover, the presence of ammonia clays on Ceres provides an additional fascinating clue. Ammonia has the ability to lower the freezing point of water, which could have allowed liquid water to exist on the surface in the past, or even today. This discovery suggests that Ceres may have formed in the colder outer regions of the solar system before migrating inward to its current location. Many of Ceres' intriguing features, including the presence of ammonia and indications of cryovolcanism, may be explained by this migration history. As scientists continue to examine Ceres' surface and interior, new findings are reshaping our understanding of planetary formation, the potential for extraterrestrial life, and the geological activity occurring beyond Earth. Once considered just another small, cold asteroid in the belt, Ceres has evolved into an intriguing world that challenges our expectations and invites us to rethink what is possible in distant celestial bodies. The Dawn spacecraft played a crucial role in uncovering these details. Through years of meticulous observation, it provided the most detailed images and data of this distant dwarf planet. The mission remains a cornerstone in our exploration of the solar system. Each new image transmitted back from the spacecraft reveals additional secrets, showcasing a complex and evolving world that was previously unknown. However, the discovery phase is only the beginning of what looks to be an ongoing investigation into the mysteries of the outer solar system. In the coming years, the scientific community will undoubtedly continue studying the data sent back by Dawn in search of more clues about the potential for life on Ceres and other similar celestial bodies. As new technologies emerge and new missions are launched, it is likely that even more surprising revelations await. Will we uncover further signs of cryovolcanism? Will we gather additional evidence of water beneath Ceres' surface? Only time will tell. But one thing is certain: the story of Ceres is far from over.